Thank you, everybody, and thank you for coming. We managed, only 2 minutes late. If it craps out, it's because we're on Zoom, and so we're using the Wi-Fi, right, to display. This is one, it's not my laptop that's displaying, it's a laptop that is connected to a Zoom call as a workaround. So that might affect the quality. Thank you. This is about using Jupyter and AI in teaching. And where do I come from in this story? Well, the story is that I have been teaching with Jupyter for a long, long time. And in 2018, this is just from my website, I created, with some help of some technical folks, a plugin to be able to read Jupyter notebooks into an LMS called OpenEdX, which is open source. We also created a plugin, some extensions to be able to grade Jupyter notebooks on the LMS, auto-grade the Jupyter notebooks using MB Grader. And it was a great system. I was very happy about this. And then I had, let's see if the video works. Yeah, it went to YouTube. I did not want that to happen. It's supposed to play on the presentation, and I won't do it here. This was just a screenshot showing the course and the LMS. For some reason, let me see. Let's give it one more chance. This is supposed to play there, but instead it's going to YouTube. Apologies for that. So the student was able to download a Jupyter notebook, work outside, upload the Jupyter notebook, and the system would automatically grade their assignment and show them what's right, what's wrong, and they have multiple attempts. And so the idea of this design was to achieve mastery, giving multiple attempts to the students, right? And that's the video. Dear, there it is. Okay, I had to just move on to one slide. And so this is using the same platform that edX.org was using at the time. And the difference is that we were able to create create courses using Jupyter notebooks. All the Jupyter notebooks lived on GitHub, so we have version control, and the Jupyter notebooks are displayed within the course sequence with these X blocks that we wrote. So we put a lot of effort into creating these integrations to be able to use Jupyter as the source of the content and also for our auto-grading. But moving along, this is in the context of this course. I gave this talk at SciPy on this course, explaining the concepts and the design principles behind these learning modules to teach undergraduate engineering students to use Python in the context of learning their engineering topics. And there's a paper that I wrote about that too, explaining the rationale of presenting computing to engineering students in context, meaning that instead of teaching programming by itself, the syntax, data structures, and all that, we are using coding as a tool for learning in the discipline. The key features of this was the lessons are all freely available online, and of course in the open source model, they were teaching computing in context. They were modular, so the idea was other people could maybe pick up small bits, small chunks of our courses instead of trying to adapt a whole course, and they lived in this OpenEdX platform, an open source learning management system with Jupyter Notebook Viewer and AutoGrader integrations. This was developed over some time, and I have been very proud of that and taken advantage of it for many years. Then also we got together and I hosted at George Washington University a Jupyter community workshop where we worked on writing a handbook on the multiple ways people were teaching and learning with Jupyter. And this, to this day, actually it needs a very serious renovation, this handbook, but nevertheless, people continue to cite it and consider it impactful. And then also, I was very excited. In 2023, I had a sabbatical, and so I learned all about AI was hitting the scene, and so I wrote another module about using Jupyter in Jupyter AI within Jupyter Notebooks, created a new set of lessons for my students. I thought this was great. I introduced it next semester in my course for the first year engineering students, which is relevant. Then I went further. I thought, cool, now we can call learning large language model within Jupyter, so maybe I can call it within a loop. And I wrote a loop to be able to use the LLM to help me in course design, and the test case that I used was using the course descriptions of the whole catalog of my department in a loop, calling the LLM to get with a nice prompt that I crafted using some tips about, of course, instructional design, the learning objectives that would describe that course. So it was just a demo, but I was very excited about the idea that we could, of course, use LLMs within Jupyter in a reproducible fashion. So I was very excited. I was like a kid in a candy shop in 2023 with all of these new things happening in AI. They continue to happen. So what happened is I come into the classroom next semester, and I decided to have a course-level AI mentor, which was a customized AI tool for my students that was able to, of course, have access to all of my course materials for retrieval augmented generation, and it had a persona that was set by my system prompt and some moderation prompts. I worked with the same technical team that helped me create those Jupyter extensions for the learning management system, and it's still, it's a really nice tool because, of course, you have the ability to put all your documents there for RAG, all of the notes, the syllabus, etc., in multiple formats. It creates automatic text embeddings with that. And then, of course, when the student prompt comes in, it is going to be augmented with the right context from the documents, and that ensures that the answers are grounded in the course materials. That's great. Also, it's not logged into a vendor. You can choose multiple LLMs, just adding an API. And of course, by API, the costs are much lower than if you decide to pay $20 per student. And we were also happy to be able to experiment with different models to see which works best in our course context. So here is just a couple of screenshots of that. This is the idea that an instructor can set the custom welcome message, the system prompt. So I could tell the AI assistant to respond in a certain way, perhaps with tutoring in mind. There were some moderation prompts as well to curtail inappropriate uses, and safety prompts to filter the results and ensure that it's appropriate for the classroom. And of course, never again have to answer emails about what is in the syllabus, because students quickly realize that they can get the answers much faster by just asking the AI mentor. So I was very happy about all of these experiments. And the answers are grounded, not only grounded in the coursework, but sometimes the answers would even use the correct variable names that were being used in the lessons. And so in many ways, then I thought it would be most helpful for the students. But we have to remember that AI needs learning science, and so you might ask, why bother? And the answer of students are, of course, using multiple AI tools, mostly ChatGPT, and they call it chat, and so we don't have to do anything. But the reason is that to be effective in the context of education, we do want to inject some learning science. And there's a recent, well, not so recent anymore, randomized control study that looked at two groups. There are very few randomized control trials in this context. Looked at two groups, one using ChatGPT out of the box, another one using a GPT tutor with some pedagogical guardrails. And they found, of course, that the group that used the tutor was doing a lot better, and the group that used just ChatGPT out of the box performed much worse in a subsequent exam. So that's very interesting, and here's a quote from that paper. AI has the potential to improve human performance, but must be deployed with appropriate guardrails when learning is important. Yes, so this is what I saw. Students quickly adopted this pattern where they would just start copying and pasting questions into the chatbot. Well, these ones are about just things that are in the syllabus, but then here we have by the way, I had access to the chat histories of all the students, so I could monitor afterwards what was going on. And I quickly started seeing these patterns where students would just copy and paste the full questions for their assignments into the chatbot, expecting to get the answer in one shot. And they just did this, and remember this platform I have where they can upload their assignments and get immediate feedback on what is right and what is wrong? Well, they can use this tool plus the autograder in an iterative fashion, trial and error, to get the right answers without thinking. So very quickly I started to see that students were copying the questions without thinking at all. Even the places where it says your code here, they would give that to the LLM. Even the places where oh, by the way, they're wanting to get some code out of here, and I have some guardrails that say in the system prompt to behave a certain fashion. So sometimes the responses were not exactly the answer, but the student would insist they don't want pseudocode, they want the code. And yes, can you make the code show, and not just the pseudocode? The student insists they really want just the answer. Even they would copy the URL of the data into the chat interface without even thinking that there's just no reason for the LLM to do anything with that URL of the data, and so on. So that, make the long story short, this was a disaster. The unintended consequences of this experiment that I was so excited about was the use of the autograder with the AI by trial and error meant that the students were completing all their tasks with no thinking, no engagement whatsoever. Attendance dropped to 30% when students figured out that they could just complete the assignments, get good grades, and they started prioritizing other courses. That's understandable. Now, the class dynamics also collapsed because when I realized all that's happening, I started to push back, and I tried to start thinking and talking to the students about their behavior, and they were very upset, of course. I not only let them use AI, I encouraged to use AI. I designed an AI tool for my course, so how could I possibly then be telling them not to use it or to use it in a certain way that, and moreover, I started thinking about an exam condition that might perhaps take away this AI tool, and this was, of course, unacceptable to them at that point. So the thing that I observe is, of course, many instructors have observed that students can over-rely on AI and that harms learning. But what I also saw is that AI can harm learning in a very strange way because it gives them the illusion of competence. This is a well-known cognitive bias that leads a learner to overestimate their knowledge and skill. But when they're getting good grades and they're seeing those assignments complete and they're seeing the solution, they have a sense, the same sense that they have in a very clear lecture. When they walk out the lecture and say, oh, that's a great lecture, I understood everything, and they try to do the assignment, and of course they can't, because it's the illusion of learning. Something just sits temporarily in your short-term memory and you think you learned it, but you really didn't. This is a well-known and studied cognitive bias, and I recognize that happening in front of my eyes. The transfer to long-term memory, the real learning, does not occur without forgetting, recall, repetition, and what we call desirable difficulty. All the passive techniques that students use a lot, like reading and highlighting, they create this illusion. Students think that they're studying, but they're not really learning anything. They're just highlighting and passively going through the material. And this causes learners to become overconfident and stop studying prematurely. Only active engagement is the antidote to this illusion. So we face some serious challenges. Do we do a secure exam? Well, I considered this, and I talked to my students, and they panicked at the idea of a secure exam setting where they would only have access to whitelisted websites. This is, by the way, what the computer science department in my school, in my university, is doing. And policing students just sucks, like being after them, and I'm, you know, this cop stuff that we have to do sometimes, a professor, is really unpleasant, and it creates a bad atmosphere and a bad mood. So what else to do? Well, I thought, well, I could remove the multiple attempts at the autograder, one and done, and I did that, and I got very poor results despite access to the AI tool during the exam. And also the student backlash was really tough. This caused, all of this dynamic caused the worst student evaluations of my entire career. An overall rating of 2.3 over 5, where the same course with the same instructor and the same materials 2 years earlier, because remember I had sabbatical in 2023, was giving me a 4.8, and that was just coming after COVID, so there was no real explanation. The only difference is this AI disaster. So there's some quotes from the student evaluations. AI has ruined this course, the student says. It makes the assignments extremely easy, and its availability makes her class easily ignorable by students. Yes, it's true. Another student, banning AI would drastically make this course more useful and fair. A majority of people would fail to be competent in the subject if AI were taken away. Indeed, they recognized they were not learning. So what are the lessons here? First, a set of unproductive moods spread in the classroom. I became frustrated, and they were confused. There was impatience, anxiety, overwhelm. All of these are additional blockers to learning. Then the question of assessment validity. Now we have to face reality. If the assignment depends on students not using AI, and we cannot prevent, we're not supervising them, then we have to admit the assessment is invalid. And AI is too ubiquitous. Banning AI does not prepare students for the world where they're going to work in. Besides, it's everywhere in everyday tools right now. So it's a very difficult problem. Now, you started thinking how to develop true competence. What is the antidote for this illusion? Of course, the antidote is the same as it was with clear lectures: active learning, reflective practices. And the fact is, unsupervised students will use AI no matter what you tell them to do. Discursive attempts to curb AI do not work. They are beginners, they're not self-regulated learners, and we face a very, very deep design problem. Everybody talks about, just redesign your assessments. It's a huge effort. We have to also restructure classroom activities to promote this engagement. But this is what we face, and this is what I would like to propose to you, that a technology creates its own pedagogy. Technology, of course, influences pedagogy by opening many new possibilities and ways of interacting with information and with each other. But of course, human agency matters. I'm not saying that this is some sort of determinism, technological determinism, but we have to, as educators, creatively adapt and use it to enhance learning, and this is a big challenge. We need to rethink not only the assessments, but all of our learning activities for the AI era. And this is not a small feat. Designing guided exploration, reflection prompts, leading students to reflect on how AI helped them. I tell students now to use AI to explain code, not to generate code, but then you have to, of course, model that practice. And then also collaboration. In my mind, quickly collaboration became a way out. Working together to discuss AI outputs and working with classmates. Because learning occurs through conversations. This is an idea that goes way back to Gordon Pask, who was a pioneer of cybernetics in 1970, who wrote a book called Conversation Theory. And conversation in this context involves an exchange between two participants where each participant is contextualized as a learning system whose internal states are changed through the course of the conversation. And his theory suggests that learning is a social process where knowledge is made explicit through interactions. And it emphasizes that meaningful learning happens when people engage in dialogue. And so, mind you, conversation can never be passive. So the role of the machine, according to Gordon Pask, is that human intellectual activity exists as a part of a resonance loop where information can go through a human to an apparatus and back to an individual, and the role of the machine is to be rich enough to maintain the dialogue, or in other words, to be a source of resonance for that conversation. He actually wrote quite a bit about computer-aided instruction, and he said that the role of the machine is to foster these conversations and think of machines as an amplifier. So what was my redesign the first time around? No homework. Everything in class, all graded work done in class in collaboration with other students. I had to take down all of those artifacts that I had created over years, which was a huge bummer for me, of course. A lot of investment into creating these artifacts for my class, but they were broken, completely broken without repair. So we have to also admit that AI literacy needs to be part of the curriculum. We have to provide guidance and dialogue. The results after this first change was attendance was 95%. Students were still unhappy because so much graded work. They were not prepared for that. They didn't know what to do at home because I took away homework. They don't know how to study. I discovered that I had to introduce a new change to give them extra exercises to do at home to prepare for the graded work in the classroom. And the final redesign that I have incorporated this semester is what I call the conversational exam. Now, this, I call it conversational exam. It's an oral exam, but it's conversational. I'm getting inspiration from conversation theory from Gordon Pask. And so I created a format where students would come into my lab in groups of 5 or 6, and they would have to do live coding in these small groups, in person, of course. They all join a Zoom meeting and simultaneously share screen. It is projected, and I had 2 rounds of questions, one easy for 2 minutes, one harder for 3 minutes, and I bought those kids' sound clocks from Amazon for $6, which were instrumental to achieving this design. For each question, I also had a hint, an elevated concept check, and a simplified question if the student was stuck. So this is for 58 students. It was administered over 2 days, 6 slots per day. Of course, it was a marathon, but yes, the grades were posted in 2 days because we had a question worksheet, and I worked with an assistant professor and a TA to do this, and we kept it all running like clockwork using these kids' sound clocks. This is an example of the matrix for grading. We had a bank of 60 questions, 30 per round, and a 1-page grading sheet per question. The students had to draw a question from a brown bag as we were going around. So it was a very elaborate, if you will, format, but we had this grading scheme, and we would just grade on the fly and then use those sheets at the end to be able to calculate the questions, and it was possible to do. But, you know, creating this exam, 60 questions, and also remember for each question I'm going back, I had a hint, an elevated concept check, a simplified question, is a huge amount of work. So what did I do? I used AI. So we use AI against AI. AI Assistant allowed me to create the bank of questions, allowed me to generate the question variations. Of course, it was all checked, but it was work that was possible to do thanks to having AI. I couldn't do it just by myself. Also, creating those worksheets was something that I had to automate on Markdown using the VS Code agent, you know, because the thing had to fit on one sheet. You know, it had to work, and there was a lot of formatting and involved AI for all of that. And then creating all of the additional home exercises, as I mentioned, I had to do. Also something that Gemini helped me with. I could export to Colab, then download to IPYNB, and so I could provide those extra exercises for my students. But while we're talking about Colab, Colab did something this year which really, really shocked me when it happened to me live as I was using Colab to do a presentation. And suddenly, this is just a screenshot from a particular lesson where I'm typing, live coding a lesson, and boom, ghost code appears. They did this silently, and then suddenly the students that are using Colab are getting not only the ability to copy and paste into ChatGPT or even my own course mentor, but are getting correct code suggestions, and they can just tab away. So I met Jake Vanderplas at SciPy in July, and I told him of my woes, and he said, let me get in touch with the Colab team. And after a lot of conversations, they came up with an idea of inserting a metadata field into the Jupyter notebook that would say no AI to the notebook. And so as long as I would prepare the notebook ahead of time and distribute it to the students, I could preset that notebook to be no AI, and that gets rid of those code suggestions. Wonderful. Now, however, the students could still go back to the settings and undo that little check, but they haven't found out yet. They're still not that computer literate to find and undo this promise. So it's still working for the time being, at least with the beginners. So it's all a balance. I do want them to use AI. I teach them to use AI, but there are certain settings when you have to not have the training wheels. So this is my last slide, and this is the professor's dilemma, right? It isn't whether to use AI in teaching with Jupyter, in teaching computing, but how to design the learning experiences so that we can harness AI's power while maintaining that cognitive effort that is necessary for genuine learning. This is a huge design problem, and it requires deep thinking, and it does help if we do it in collaboration. It requires a lot of experimentation and failure. In fact, there is no innovation without failure.